we have 21.4. You want to, but you can leave the answer over here, 21.4. But remember to add the units. Okay, so this becomes our mode. Is that okay? Great. All right. Thank you. All right, so this is our last question on the grouped frequency table, how to calculate for mode on the group frequency table. So this table actually presents 40 patients who went for screening, okay, BMI screening, okay. So with this question, what we have to do is that we have to first confirm whether it's a group data. So of which, if you look at it, it is a group frequency table because of this one. You see that it has been grouped, okay. So after you have confirmed, so this is the variable column and this is the frequency. So now what you have to do is that you have to first identify your modal class, okay. And in identifying your modal class, you have to look at the highest frequency here, then use that one. So over here 13 is the highest frequency, so therefore the modal class is what? So analysis. So our modal class is what? So the modal class is what? 22 to 24. Okay. So of which it answers the question number 1. So now the next thing is that the question says that using the formula for group frequency table, we have to calculate for the mode. So with this one, we use the formula, and this is the formula. Mode is equal to Lm plus okay. So this is the formula. So this one, where the Lm is our lower class boundary, okay, of the modal class, okay. And then the F1 is our frequency of the modal class, okay. Then F0 is the frequency of the frequency before the modal class, okay. So frequency of the class before the modal class, okay. Then so I've explained the F1. The F2 is the frequency of the class after the modal class, okay. So we know that this is our modal class. Do you get it? So now another person too can do a table and include the class boundary, so that it becomes easy for the person. But notwithstanding, for you to get a class boundary, you want this one minus this divided by 2, which is what? 0.5. So that's 0.5. You subtract it from this one, you add it. So let's quickly let's add the class boundary to it and see. So with that one, we have here to be what? 15.5 to 18.5. Then here becomes 18.5 to 21.5. Always this and this become the same thing. So here will be 21.5 to 24.5. Then here is 24.5 to 27.5. And this is what? 27.5 to 28 to 30.5. So now so let's first write our parameters. So in writing our parameters, we can say that the Rm is what? It's talking about the lower class boundary of the modal class, and this is our modal class. So this is the lower class boundary, which is what? 21.5. Okay. Then we have our F1. So the F1 is the frequency of what? Of the modal class, and the frequency of the modal class is what? 13. Then F0 is the frequency before the modal class. So if you look at it, this is the modal class. So the frequency before it is what? Is 8. And then our F2 is frequency after the modal class, frequency. Okay. So that one will be what? 9. So now we can put everything in the formula. So we have, okay. Now the H, So the h is the class width, okay, or the class size. So with that one, to calculate it, we have to see this one is the, so we have to just what, subtract this from this, okay. So that's going to be 24.5 minus 21.5, and that's going to give us what? That's going to give us what? 3, 4 or 3. So calculators. So that's going to give us 3. Okay. So here becomes what? 3. So in putting it into the formula, we will have what? Mode to be 21.5 plus, we have this one to be what? 13 minus 8, 2. Our F1 is what? 13 minus what? F0, which is what? 8 minus F2, which is what? 9 times what? 3. Okay, so board mass have to be applied over here. So with, because of board mass, so we have to still repeat this one. Then we add everything in the bracket. So in adding everything in the bracket, please, what are you getting? Yes, add everything in the bracket. 30 minus this, whatever. So this one is going to be 5. Anyway, if you want to calculate it slowly, so this one will be what? 6. Okay. So multiply it automatically. This one here is 2. So what are you going to get? It's 9. Okay. So now, if you want to use mathematics, we would have said that, okay, now you have to multiply. So just multiply and let's see. 9 over 5, 5 over 9 times 3. That one is going to give it, which, oh, 5 over 9 times 3 will be what? 1.7. Okay, so now add the 2. So in adding the 2, what are you going to get? Are you sure? 23.2. Is that what you are getting? Okay. So BMI, is it a discrete? Is it a discrete or continuous? It's a continuous. So that means that we can maintain the answer like that. Okay. All right. So that means that our mode is what? 23 point what? Point 2 what? And then the unit of BMI is what? Okay, kilogram per what? Meter square. So this brings us to the answer for mode. Okay, so let's go over again. We said you first have to find what? Your modal class, and in finding the modal class, you have to look at the highest what? Frequency. So the highest frequency is what? 13. So therefore, this becomes what? Our modal class. After we have gotten the modal class, we have to then find for, so we can add the class boundary to it. In adding the class boundary, okay, we said you just subtract 18 from 19, you get 1 divided by 2, which is 0.5. You subtract it from this side and you add it to this. So it becomes what? 15 point this, that. So like this. So now this one is talking about the lower class boundary of the modal class. So, and this is the modal class, okay. So therefore, it becomes what? This 21.5. Then we say that the F1 is the frequency of the modal class, and frequency of the modal class is what? 13. Then our F0 is what? Frequency before the modal class, which is what? 8. Okay. And then F2 is what? Frequency after the modal class, which is what? 9. So you put that into the formula, then you solve everything, and you what? Arrive at 23.2 kilogram per meter whole square. So this will bring us to the end of what? The Grouped frequency table, how to calculate for the mode. Okay, bye.
Shows the systolic blood pressure of 45 patients. So the first question has asked us to calculate for the modal class. So in calculate for the modal class, look at the class with the highest frequency. So checking the table, we have 14 to be the highest frequency. So you trace it to the class, and you are having 120 to 129. So the modal class for the first question is 120 to 129. The second question has asked us to calculate for the mode. And in calculating for the mode, the formula is LM, which is the lower class boundary, plus F1. The F1 is the frequency of the modal class. And the F0 is the frequency of the class before the modal class. And the F2 is the frequency of the class after the modal class. And you have the H to be the class weight. So you have to identify our parameters first. So lower the lower limit, to get the lower limit, we're going to subtract 0.5 from the lower limit. So you are having lower limit minus 0.5. So I'm going to have 120 minus 0.5. Then we get 119.5. Then our F1 is the frequency of the modal class. So the frequency of the modal class is 14. And frequency of the class before the modal class is 9 from the table. Then the frequency of the class after the modal class is 10. Then we have the class weight to be the upper limit minus the lower limit plus 1. So I'm going to have 129 minus 120 plus 1, and which will be 10. So I'm going to compute our values into the formula to get the mode. So you have the mode to be equal to, we have our LM to be 119.5 plus, then our F1 to be 14, then our F0 to be 9. So we're going to have 2 times 14 minus the F0, which is 9, minus the frequency after the modal class to be 10. Then we multiply by the class weight, which is also 10. Okay. So here you have to solve the one in the bracket first because it's a board mass. So when you subtract the 9 from the 14, you get 5. Then here you get 2 times 14 is 28. 28, so okay, 9. Okay. Times 10. Okay. So you're going to get 119.5 plus total 0.5 times 10, which will be 5. 5.55. Okay, so we're going to have our final answer to be 125. Okay, millimeter of mercury. Okay, so we have our mode to be 125 millimeter of mercury.